All right, let's keep moving with hypothesis testing. We're going to do 7.2. I got another math humor there. The guy's asking him if she'll marry him, and she says, I reject the null hypothesis. Okay, so we are going to start comparing the p-value, which we're going to find using StatCrunch, with the level of significance. And of course, that's going to be that alpha that looks like that. So remember in 7.1, we looked at left tail tests. That's when the area was to the left, and our alternative hypothesis, the inequality pointed that direction. We also have a right tail test. That's where the area is going to go to the right. The alternative hypothesis will point that direction. And then finally, we have a two-tail test. That is when the alternative is not equal to. So it's not pointing either direction, and so we're going to use both tails. So this is really important as we get started with this hypothesis testing. Okay, so I know there's a lot going on here, but let's kind of take it piece by piece. So it says find the p-value for a left-tailed hypothesis test. All right, so I'm going to draw that down here. It tells me that it's a left tail, so I'm going to be pointing to the left. They tell me the standardized test statistic z is negative 2.23. So remember, z is always on the number line. So negative 2.23 is this point right here where the shading stops. And then we're going to compare that with a level of significance of 1%, 0.01. Okay, so the first thing we have to do is go to StatCrunch and figure out our area. So we're going to go to calculator normal. Our mean and our standard deviation are going to stay at 0 and 1. We want to point to the left, and we're going to put our z statistic here of negative 2.23. When we do that, we get our p-value right here. And so our p-value is 0.013, let's say. Let's round it. Whoops. 0.013. So we now have to compare that to 0.01 because that's going to help us decide whether we're going to reject or we're going to fail to reject. Okay, and so since the, remember this is p on this side, this is alpha on this side. Since p is greater than the 0.01, we are going to fail to reject. Okay. Okay, let's look at another one, and then we'll go back and look at the rules with p and alpha all on one page. Okay, so this one tells me I have a two-tail test. So if I have a two-tail test, I'm going to have area on both sides. Right? Then it tells me that my standardized test statistic is 2.14. Right? So what that tells me is on this side, I have 2.14. On this side, I have negative 2.14. All right. And we're going to compare this to a level of significance of 5%. Okay, so what we have to do in StatCrunch is we have to find that area. So we have to do it twice because it's on the ends. And so we're going to go into calculator normal again. First, we're going to point to the left and put our negative 2.14 in there. That gives me an area of 0.0162. And then I'm going to do it again. This time I'm going to point to the right and put positive 2.14. That takes care of the area on this side. And that gives me 0.0162. When I add those together, I get 0.0324. Okay, so this is my P, and I'm comparing it to my alpha. Well, P is less than the 0.05, therefore I am going to reject my null hypothesis. Okay, let's go ahead and talk about p-values again. Let's do a visual here. So if the p-value is less than alpha, we're going to reject. If it's greater than alpha, we're going to fail to reject. So let me show you some examples here. So on this one, my p-value is 0.03. And let's say that, let's make my alpha, so this is P, let's make my alpha 5%. Okay, so you definitely can see that the p-value is less than alpha. And so that means that I'm going to reject. What happens on the graph, hopefully you can see this yellow. This is 3%. If I look at 5%, the p-value is completely contained inside of my 5%, right? So the yellow is the 5%. I don't have any values in my acceptable range. So this is kind of my fail range here. This is where I reject. On the other side here, this side is where I fail to reject. And all of my p-values are inside the region where I'm going to reject. Okay, so let's look at the other one here. Let's say I have 0.03, and let's let alpha be 1%. Okay, so this time my p-value is greater than my alpha, so I'm going to fail to reject. And what happens is my rejection region is over here. It's very tiny, right? This is my 0.01. And so this is my rejection region over here. This is my fail to reject region over here. And you can see that I have some of my data values in the fail to reject region. And so I'm not sure if I can reject or fail to reject, and therefore I'm going to fail to reject. So I hope that gives you a little bit of a visual. We'll keep going and look at more of those. All right, so this is just a reminder of all our formulas. We already know how to do this. The z-score is going to be the sample mean minus the hypothesized mean over the standard error. If we are using a sample mean, of course, we have to adjust our standard deviation by the square root of n. We again have to know that either the population is normally distributed or that the sample size is greater than or equal to 30. All right, and again here, this just has all of those things put together. It also reminds you of when we're going to reject and when we're going to fail to reject with P and alpha.